going to be an introduction to exponents. So first off, how can I determine if something is an exponent? First thing I need to be able to do when they give me a problem is determine what is an exponent and what is not an exponent. An exponent is always going to be small, and it's going to be above to the right of another number or a variable. So here's some examples. So here are two examples. This small number right here, which is above and to the right of this number right here, that 2, is my exponent. For this example, I've got a 3 that's above and to the right and small above this x right here. That 3 is my exponent. The 2 is my exponent for this example. 3 is my exponent for this example. So how am I going to say this? Another word for exponent is power. So I can say this is 9 to the second power. This is x to the third power. So another word for exponent, or the way you describe this exponent, is by using the word power. So to describe an exponent, you're going to use the word power. However, there are two exponents that have special names. The two exponents that have special names are an exponent of 2, which can be called squared, and an exponent of 3, which can be called cubed. So looking at these two examples up here, I could say that this is 9 to the second power, or I could say it's 9 squared. This one, I could say it's x to the third power, or I could call it x cubed. So, what are exponents telling me to do? This is what an exponent is telling you to do. It's telling you to take that large number or that variable and multiply it to itself that many times. So let me say that again. That little number is telling you to write that number, larger number, down that many times and multiply it all together. Here is an example. Three to the third power, or I could say 3 cubed. That means I'm going to take this 3 right here and I'm going to write it down that many times. 1, 2, 3. And I'm going to multiply it all together. So following my order of operations, I go in this direction. I multiply those two together first. 3 times 3 is 9. I bring down the rest. And then 9 times 3 is 27. Here's another example. 4 to the fourth power. That means I'm going to have 4 written down 4 times. And I'm going to multiply them all together. So the exponent tells you how many times you write down the larger number. 4 times 4 is 16 times 4 times 4. 16 times 4 is 64 times 4. And 64 times 4 is 256. Now the large number, or the variable, is called the base. We may need to know that. So if they give you an example like this, 4 to the third power, or 4 cubed, this part right here is my exponent, and this 4 is my base. Another example, x to the fifth power. The 5 is my exponent, and the x is my base. So we've already talked about two exponents that are special in the sense that they have special names. An exponent of 2 has a special name, squared. Exponent of 3 has a special name, cubed. There are two other special exponents, an exponent of 1 and an exponent of 0. Let's talk about an exponent of 1. So sometimes you'll see them actually write the exponent 1 above the number. If something has an exponent of 1, how many of those are there? In this situation, 8 raised to the first power is simply going to be 8. If I have x raised to the first power, that's going to be equal to x. If I have 10 raised to the first power, that's simply going to be equal to 10. This is telling me that there's only one of these numbers. There's only one of these variables. If you do not see an exponent, then the exponent is 1. A lot of times they won't write an exponent of 1. This kind of understood that there is an exponent of 1 above each one of these numbers. So let's look at this example. This is 5 to the third power, or you can say 5 cubed. This is 6 to the second power, or you can say 6 squared. 4 raised to what power? Since you don't see an exponent, there's an exponent of 1, so this is 4 to the first power. Again, this is x raised to the what power? Fourth power. This is x raised to the what power? Ninth power. And this one, x is raised to the what power? First power, because you don't see an exponent. So an exponent of 1 is an exponent that you don't always have to write down, and most of the time they will not write it down. The next special exponent is an exponent of 0. Anything raised to the power of 0 is equal to 1. As soon as we get to our dividing variables section, where we have to take variables or take things with exponents and divide them, we're going to go over why something raised to the 0 power is equal to 1. But right now, we're just going to try to remember that anything raised to the power of 0 is equal to 1. So, 4 raised to the power of 0, 1. 10 raised to the power of 0 is equal to 1. X raised to the power of 0 is 1. So let's try some problems that involve using exponents. This is 9 raised to the third power, or 9 cubed. That means I'm going to write 9 down how many times? 3 times. And I'm going to start multiplying these numbers together. 9 times 9. 81 times 9. 729. 5 raised to the fourth power. That means I'm going to write down how many 5s. 1, 2, 3, 4. 5 times 5, 25 times 5 times 5. 25 times 5, 125. And 125 times 5, 625. Find 1 to the 6th power. Well, what's 1 times 1? 1 times 1. 1 times 1. 1. Doesn't matter what the exponent is on 1. Every time I multiply by 1 and keep multiplying by 1, I'm constantly going to get 1. So 1 raised to any power is going to be 1. 12 to the first power. How many 12s am I going to write down? 112. 10 raised to the power of 0. Remember, anything raised to the power of 0 is going to be 1. Now they're asking us to figure out what the exponent is going to be. What power can I raise 10 to and get 1,000? So I'm going to try 10 times 10. 10 times 10 is 100. Multiply it by another 10. 100 times 10 is 1,000. How many tens do I have there? 3. X is equal to 3. Now, one thing about multiplying by tens, 10 times 10 is 100. Look how many zeros are here. Look how many zeros are in my answer. Then I multiply it by another 10. I just add another 0. So every time I multiply by 10, I'm simply adding another 0. So I'll look over here. How many zeros do I have? I've got 3. That's going to be 10 to the third power. That little trick is going to help me solve these other problems. What exponent goes right here? The only thing I have to do is look over here and see how many zeros I have. X is equal to 2. I'm going to use that same trick on this one. X is going to be equal to, the only thing I have to do is count the zeros over here, and I'll get what power I need to raise 10 to get this number right here. 1, 2, 3, 4, 5, 6, 7. 10 raised to the 7th power is this number right here. X is equal to 10 raised to what power? Gives you this. The only thing I have to do is count the zeros. 1, 2, 3, 4, 5. Remember, the only thing I have to do is count the zeros. What power can I raise 10 to and get 10? The first power. Again, the only thing I have to do is count the zeros. How many zeros do I have over here? I don't have any. In fact, what power can I raise 10 to and get 1? What exponent creates a 1? An exponent of 0. So let's try some that don't have 10 as the base. What power can I raise 5 to and get 25? So what I do is I start multiplying these together. 5 times 5. 5 times 5 is 25. What takes that many 5s? So X is equal to 2. 5 raised to the second power is going to be 25. When I get to this one, I start multiplying 7s together. I need to see how many 7s I can multiply together to get this. How many 7s can I multiply together to get this? 7 times 7 is 49. Times 7 is equal to... So how many 7s did I need to multiply together to get this? 1, 2, 3. X is equal to 3. How many 2's do I need to multiply together to get 16? Start multiplying 2's together. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So how many 2's do I need to multiply together to get 16? 1, 2, 3, 4. X is equal to 4. How many 6's do I need to multiply together to get this number right here? I start multiplying 6's together. 6 times 6, 36. Times 6, 36 times 6, 216. Times 6, 216 times 6 is 1,296. How many 6's do I need to multiply together to get this number right here? That exponent is going to be 4.